So I'm the VP of Product at MayaData. MayaData is the main sponsor and contributor behind the popular OpenEBS project, among other open source projects such as Node Disk Manager, Litmus, and our new project, KubeMove. It's a pleasure to have Jason Van Brackel, Director of Community from Rancher Labs, and our own wise guy with the beard, Patrick Hoolboom, Senior Developer Advocate of MayaData, with me today on the call. If you are in the community long enough, you probably know Jason already. He's responsible for enabling and engaging the Rancher Labs open source community by developing programs to train, enable, and motivate technologists implementing Rancher Labs technologies and other complementary CNCF and open source projects. Jason has over 10 years of experience using technologies and also Kubernetes to assist organization developing next generation cloud native applications. And Patrick assists developers or DevOps oriented users of Kubernetes and designing and deploying stateful workloads. Patrick has years of expertise in DevOps methodologies and closed-loop automation in data centers. Here is the short list of things we will cover today. If you are coming from one community or the other, we will cover both OpenEBS and Rancher solutions briefly on this call. And of course, we'll discuss the joint solutions and benefits. Both solutions have a lot in common, whether you have an open source policy or not. If you are a user of OpenEBS or Rancher, you will definitely like the combined solution. Patrick will take control after and give us a cool live demo. Yeah, we don't like recorded demos, so no pressure here, Patrick. But and then Patrick will also give us an update of the OpenEBS project, what's new and what we and other contributors have been working on recently. And no spoilers, of course, but something very important to enable specific type of stateful workloads have been introduced recently. And finally, we will take questions during the Q&A sections. So, and why are we today has a lot to do with this sentence. Application have changed, and something forgot to tell storage. Cloud native applications are distributed systems themselves and uses variety of protocols to achieve consensus, Paxos, gossip, etc. And also, is a distributed storage system still needed? Today, applications are designed to fail and expected to fail, and additional details to consider when planning, like across rack or zone availability, DCs, regions, and providers. Sometimes scalability batteries included, like HA proxy, Envoy, Nginx, and also data sets of individual, relatively small in terms of I/O and capacity applications increasing. Databases provide various forms of scale out, and then the rise of cloud native languages such as Pulumi, Ballerina, and Meta, Particle, and others. There are also important lessons we have learned from the DevOps practices and then Kubernetes itself. Per team control, small teams need some agility they have in development when consuming infrastructure. Similar agility needed. No tight coupling to infrastructure, so it can easily break pipelines. And then also it's important to be able to run the same code everywhere without the lock-in. Well, it turns out Kubernetes solves a lot of these issues here by providing orchestration for the new packaging, what we call containers, and actually makes the cloud vendor's commodity as long as you run on your own infrastructure, and most importantly, storage. And because storage has gravity, not easy to move, and it's also true that if you are accidentally locked into a legacy vendor or directly consumes cloud storage, then your teams lose autonomy and end up over provisioning most of the time, means a higher TCO. And there is also what I call a cloud wash type of solutions trying to ride the cloud native trend, and because of all that, large enterprises choose no storage at all, increasingly prefer to traditional storage systems and services. We have to consider all of these when architecting the next generation container attached storage solutions. CAS stands for Container Attached Solution, and OpenEBS is now the leading open source container attached storage and 100% open source, 100% in user space. It provides storage abstraction layer for your stateful workloads on Kubernetes. Also 100% Kubernetes native itself is orchestrated by Kubernetes and enables your DevOps team to have full control over the storage layer. One storage controller per application with its own policies means much better granular control, and it just works with any storage backend on any legacy or cloud storage vendor. In addition, OpenEBS benefits MayaData provides enterprise data agility platform, which provides visibility monitoring tools. And Maya Online is part of it. Maya Online provides visibility, all this visibility monitoring and logging, and also support, enterprise support tools through its interface. And Litmus is another open source tool to simplify onboarding stateful applications that you can use for chaos engineering and end-to-end testing. And separately, Maya Online integrates tightly with MayaData's data migration as a service feature, DMAS, and the new project called Cube Move gives you simple backup and data migration. So OpenEBS with Rancher provides a complete solution for building and running stateful application on Kubernetes. And it's a recent announcement, OpenEBS project started by MayaData and recently accepted into CNCF as a sandbox project. It's an official now community project. OpenEBS is used by hundreds or probably now thousands by various organizations. And also, so like I said, OpenEBS runs anywhere. It's a big benefit and comes from the architectural differences. As I mentioned, it is completely in user space, so no kernel dependencies or no system dependencies at all, and provides enterprise functionalities. Team provisioning is one that most of the users benefit to save from storage costs, especially running on top of cloud vendors. And most importantly, it is architected to be really a simple storage solution, no new teams needed. If you know Kubernetes, you already know how to run OpenEBS. So this is a bit of commercial offering details. So OpenEBS is completely open source, and the support is from the community. And when you are ready to put OpenEBS into enterprise environment, MayaData provides support plans, enterprise starter and enterprise standard and production. So you can find all the details on mayadata.io in pricing section. It comes with multiple levels of support, longer data retention and RBAC, and also previously on a previous slide I mentioned DMAS, data migration as a service, is part of Maya Online and MayaData's enterprise support offering. A high-level overview of OpenEBS. OpenEBS itself is one of the first container-attached storage solutions, and it has all the metrics and support for Kubernetes ecosystem, meaning you can easily integrate with Prometheus and have nice Grafana graphs, and also you can take Kubernetes snapshots and clones, and you can use OpenEBS to abstract the storage layer, so you are not locked into one vendor. So using all these benefits, it simplifies onboarding and really easy to manage and saves you a lot of money from the storage side. So this is a slide from one of the KubeCon announcement. OpenEBS is introduced as an official sandbox project. And now you can find it in Cloud Native Compute Foundation projects, and you can find the keynote presentations on YouTube. So quick, before I jumped into the demo and then hand it to Jason and Patrick. So after this webinar on June 12th, we are gonna have a KubeCon Barcelona update and also OpenEBS release webinar. We will talk about the CNC OpenEBS being in CNCF and highlights of KubeCon, what was new and what's new in the ecosystem, and also some updates and demos. You can register online on following this link as well as on MayaData website. Now I'm handing over to Jason.
Good morning. So let's talk a little bit about an overview of Rancher. Over the next several years, thought leaders in our industry, distributed computing and Kubernetes, believe that most of your applications are going to run on Kubernetes. That means Kubernetes is quickly becoming the kernel for applications running in the cloud and in your data center. This means for developers, next slide. Oh, next slide. This means that for developers, regardless of stack, whether that be something legacy like a J2EE or a .NET, or even something more modern like a Node, they can bring their applications to Kubernetes either in the data center or on the cloud. The idea being Kubernetes everywhere. So developers can continue to develop software and focus on business concerns, while operations can be concerned with the jobs of operations getting those software loads into production. What that means from a Kubernetes perspective for operations teams, next slide, that regardless of the infrastructure, whether it be from the desktop all the way up to the cloud, we have consistent APIs controlling things like our security and access control, our backup and recovery, our monitoring or logging, even our networking can be consistent from the laptop into production. This means that we no longer have the it works on my machine paradigm. What the container that runs on the developer's laptop is the same container that will be running in production systems. That means for your DevOps teams, for your operations teams, they have the ability to consistently deliver operations at Kubernetes as a service, container as a service, and other such patterns across the enterprise, both in the cloud and in their data centers. So enter Rancher, the enterprise Kubernetes platform. So Rancher Labs is a company that builds open source software that allows organizations to provide Kubernetes as a service everywhere, from the developer on the laptop all the way up into centralized production, bringing everything from self-service Kubernetes environments with a consistent user interface and an API for automation, as well as logging, alerting, and then unified operations around RBAC, security, policies, anywhere, all the way from your smaller, tighter Kubernetes distributions like K3s, all the way to Kubernetes as a service in the cloud, bringing DevOps, central IT, and the cloud together as one. We do this in three ways. We work with all the various CNCF projects. We also include some with push button capabilities to easily deploy Prometheus, FluentD, Grafana, and then even with other projects like with Brio that we've recently released to do even Istio and other full scale integrations to make the developer's life and the operator's life easier. moving into the second level to provide Kubernetes everywhere, whether that be in the cloud on a Kubernetes service, providing centralized policy management, and even multi-cluster application support. So you get the idea of actually load balancing an application between your data center and the cloud. And then spreading out into essentially Kubernetes everywhere. As Kubernetes grows, we start seeing Kubernetes on the edge. Think Kubernetes, Kubernetes in your car, Kubernetes in your restaurant, and even the ability to have Windows workloads alongside Linux workloads. And with that, I'll pass the baton.
Thank you for the great introduction, Jason. And Rancher solution provides all the benefits in Kubernetes as service. And when you deploy, of course, we have a mixed environment, like you mentioned, running on the edge, on cloud, now maybe autonomous inside the cars, everywhere. So when it comes to running stateful workloads, and then storage, the layer needs to be also unified. That's where users benefit using OpenEBS and Rancher solution together. It provides you a completely open source solution. If you have, and most enterprises now have open source policies. So in that sense, highly compatible, and then we have really integrated ecosystem and user groups. And additionally, so as an enterprise, MayaData provides enterprise support on top of Rancher platform as well. You can find the solution guides using OpenEBS on top of Rancher for building cloud native on-premise solution. And of course, both communities are very active, and that's a additional benefit. So now we will have a cool demo with Patrick. So I'm gonna stop sharing and hand it to Patrick.
Great. Thanks, Murat. Give me a second here and I'll share my screen and we will get going. All right, can you see the browser in the terminal window, Murat?
Yes, yeah, looks great.
Okay, great. Okay, what I want to do today is I want to show a demo of how easy it is to install OpenEBS on Rancher, and a little bit of how easy it is to leverage that to deploy workloads. So the first thing that I want to do is we can jump over and look at the Rancher UI here. We want to go ahead and deploy OpenEBS from the catalog. So let's go ahead and do that right now. So you can see it's as simple as going to the catalog and searching for OpenEBS. I click on the view details, and there's some configuration information here that you can do. I'm going to be deploying 0.9, which is the version that we just released. So let's go ahead and deploy that now. All right, and it is deploying the daemon sets and the pods and everything that are required for OpenEBS. While that's going on, I'm going to jump over and show you something slightly different. This is Maya Online. Maya Online is the dashboard that we have for troubleshooting and visibility around all of your storage resources. So I want to go ahead and connect this same cluster to Maya Online. So I can choose on-premise Kubernetes, then click the little Rancher logo. So that way Rancher, we know it's a Rancher cluster, and you'll see that in just a moment. I give it a name, Rancher. I click connect. And it gives me a kubectl command that I can run to deploy the Maya Online bits on my cluster, and then it will connect up and begin reporting into Maya Online. So let's go ahead and run that now. Okay, and while that starts up, let's jump back over to Rancher and take a look at what we got deployed as part of OpenEBS. So if we go look at the workloads, you'll see a number of pods were deployed. So we have NDM here, which is the node device manager. That's a daemon set that's runs each node, so it's a daemon set. And it's responsible for discovering the disks so that you can actually build pools of those disks and expose them to your storage classes and your applications. The nice thing about OpenEBS is it works with any block devices that you can connect to your node. Anything you can expose as a block device, we can consume and use as storage. There's a number of other pods here that are just basically to keep the system up and running, allow us to deploy PVCs and things like that. So let's jump over to here and look at the storage classes that were deployed. We have the Jiva default storage class. That's just using the Jiva engine, which is based off of Longhorn. That's a real nice storage class for getting started and real nice engine for getting started with real basic work. The other thing that we have, which is new, is the OpenEBS host path. That's using the local PV. It allows you to use essentially like host path on the machine for if you're deploying applications that are taking care of replication and things like that on their own. This is great. It gives you very, very close to the same speed as raw IO to the disk. So let's go ahead and jump over here and let's go ahead and add some storage pools and storage classes. Okay, so if we look here, we can see that I've defined a storage pool claim. I've gone ahead and added the disks already to the disk list that I want added to the storage pool claim. Let me show you actually the custom resource that allows you to get the disks. So when you install OpenEBS, you get a custom resource called disks. So you can do kubectl get disks and it will show you all of the disks that are in your cluster. I've taken these disks and I've added them to the disk list already. You'll see that I can configure things like memory, resource limits, and things like that. So let's go ahead and provision the storage pool. So I'm going to do it just via importing YAML through the Rancher UI. And now you'll see it's spinning up the pods for the pools. So there will be one pool per node that I have. I have 3 worker nodes in this particular cluster. And then now that the pools are provisioned, we can actually go over and provision a storage class. So at the storage class layer, this is where you can configure things like node affinity for your PVCs, for your PVs, as well as replicas. So in this particular case, I'm going to point to the storage pool claim that we just created. And I say that I want 3 replicas of every PV. So essentially, the application will talk to a storage controller that was deployed by OpenEBS, and it will branch out and create 3 replicas across the nodes. So let's go ahead and create that now. So if we jump back over, you can actually see that we now have the storage class that I just created, the OpenEBS CStore test. So that was super simple to create both the storage pool and the storage class. The next step is that we actually want to go ahead and deploy an application that's going to use this storage. So in order to do that, we define a persistent volume claim, and then we mount that particular, we leverage that particular persistent volume claim within the container definition. So here is my persistent volume claim.
We have a comment in the chat. Is it possible to zoom into that screen? Letters are
which one?
Small. To your where you have the YAML file.
Oh, the editor. Yeah.
Yes, editor. Yes, yeah.
Here we go. Zoom in a couple times. How's that? Is that better? Okay.
Thank you.
Yeah, no problem. All right. So here we see the persistent volume claim. I've pointed it to the storage class that we just created. I have requested a certain amount of storage, and I give the PVC a name. And then up above in the volumes, I point to that PVC, and that's how I'm able to get a PV provision. So this particular deployment, I'm going to be deploying Jira. So I've got a deployment and a service and the PVC. So let's go ahead and deploy that now. Okay, so we'll see it's starting to spin up, provision the PVC and spin up the Jira deployment. If we jump back over to My Online, everything should be connected now, and we can go to our topology view to see how this resource is being provisioned and how these pods are being stood up. So you'll see that the way it's configured is that there are the CStore pools, and they're spread across, they're striped across 2 disks per node. So I have my 3 CStore volume replicas right here, which are being spread across the nodes, just like the pools. So this gives us a lot of fault tolerance, a lot of resiliency at our data layer. So you can see it's showing us as they spin up and as they become healthy. So if we, yeah, and you can see now that Jira is up and running and it is healthy. So if we look at the service discovery, you'll see we got a cluster IP from the service that we defined. So let's go ahead, and if we jump back over to My Online, it's still building the replicas, so you can see there the status. So we'll give that just a moment here. Was there another question, Murat?
Not related to this one.
Okay.
Yeah.
Okay, great.
We'll
All
take
right, so
the questions in the Q&A. Yeah.
all right, great, sounds good. So the replicas are now all built. So you see the deployment and as well as the persistent volume claim and everything beneath. So that's kind of the beauty of this topology pane within My Online, is that it shows you a quick glance of where your storage resource is at. It's really helpful. It's really handy. So if we click on the persistent volume claim, another really nice thing about Maya Online is that we can dig in and see, we can essentially run a describe and see what's going on with the status of that particular resource. Or for the persistent volume claims, we can click the little snapshot icon, and it's going to go ahead and create a snapshot of that volume, and you'll see that is here. And from that snapshot, we can clone it, and we can create another volume. So that's a really great way to be able to clone data and move it between environments, or share data between developers or teams or things like that. So it's a very handy way to take care of your snapshots and your clones. All right, so there we go. It readjusted. So also within Maya Online, you'll see that we do show a list of the applications that have been deployed and are leveraging storage. So that's a quick view to see what has been deployed on the cluster. Or you can go to the monitoring pane and you can actually see some stats about the particular volumes. Or you can dig in and you can click something like this button here allows the specific topology of that particular volume. So you can see it's dug in and it's removed all the other resources on the topology page. Or you can go ahead and you can view volume analytics, which is super helpful. This is actually a hosted Grafana dashboard that's just part of My Online. It's part of it, and it's really handy. It's a great way for debugging and things like that. So if I close that, and then the last thing that is offered through this monitoring pane is a hosted EFK stack. So that's Elasticsearch, Fluentd, and Kibana. So you'll see here it's pulling up Kibana so we can see the logs for the storage resources. This is really nice to have a centralized place for all of your storage logs. Also, in case your cluster becomes unavailable, you can go online and check those here. Let's go back to the overview. And if we jump back to the home page of Maya Online, you will see DMAS on the left-hand side. That's going to be coming very soon for our enterprise customers. That essentially will allow you to do asynchronous replication between clusters or between clouds. So it's a great way to replicate your data to geographically dispersed areas and things like that. So we're really excited about that. It's going to be great. All right, so that wraps up my part of the demo. So I'm going to stop sharing my screen. And Murat, if you want to share
Thank
your
you so
screen
much
again.
for the demo.
Yeah.
And you come from DevOps background, and probably you care less about the storage. And what's your favorite feature of Maya Online?
Oh, it's the topology pane. I like the topology pane the best. It's like I said, it's really easy to see your storage resources and what they're connected to at a glance. It's also really easy to find orphan storage resources. So if you have PVs or something out there that didn't get cleaned up for one reason or another, you can see them really easily there instead of having to worry about running kubectl commands and things like that. So yeah, I am really excited about that, and then I'm really excited about the DMAS coming down the pipeline because that's going to be really neat. So.
Oh, cool.
Yeah. Now what I'll do is I'll quickly go over the new features of OpenEBS 0.9. I'm not going to dive into detail about this because that's really the point of our next webinar. We're super excited about 0.9 because not only do we have OpenEBS 0.9 in production with some very large scale users, but we've also released a ton of really neat features with it. So I recommend everyone come and attend the next webinar on June 12th. It's going to be a good one. So some of the things we released, as I touched on earlier, was local PV. So you can create a PVC, use the local PV, and dynamically provision those. It's good fit for stateful sets where applications handle the replication, things like that. We have released a Valero plugin, Heptio Valero, to allow backup and restore of CSTOR volumes to S3. So this is kind of a step in the direction of what we're going to be implementing with DMAS. Only DMAS will be a lot more, and it'll be really great. But for now, if you want to be able to do those things, you can use the Heptio Valero plugin. We've also increased some of the configurability around anti-affinity and affinity for many of the pods and things like that. So it does give you some better resiliency, a better HA around the target pods, and able to kind of co-locate your target pods with your application pods. It's pretty neat. So then we also added the ability to change namespaces for Jiva volume pods. One really highly requested feature that we added is there's now a lot of performance tuning you can do for CSTOR. So a lot of users were wanting to tweak certain performance or certain aspects of iSCSI and things like that, and we're now exposing that as a configuration option. So that's really great. And then also faster rebuild of Jiva volume replicas. So that's always better. The faster we rebuild them, the better. So like I said, though, attend the next webinar and you'll get a lot more details about this. So that's it from me. So thank you, Murat.
Performance tuning is actually really why CAS container attached storage exists, right? And because you have granular control, and you want to be able to optimize your storage engines per workloads. So this was really highly expected or a nice feature to have. And also, interestingly, we have seen before we even introduced local PV, I think at KubeCon, we ran into many people being at advantage of being in open source before even it was introduced. Some users were already using in production. Again, we will cover much more in the next webinar in terms of what's new in 0.9 release and what's also coming to the next big release, 1.0. And we'll have additional demos, and we will have more highlights from KubeCon Europe, Barcelona. Quick summary. Rancher introduces a centralized control plane that unifies management of every Kubernetes cluster running across your organization. In that sense, it is one of the important parts of your infrastructure or DevOps environment. And OpenEBS easily installed, we have seen on the demo part. Now OpenEBS is part of a certified Rancher partner. You can see the logo also in the global catalog. Can be configured and managed to achieve the persistent storage needs for stateful applications on Rancher, managed Kubernetes clusters, and even on the K3s, because you will see OpenEBS also has ARM builds, can run on the edge. And Maya Online on top of it adds a nice resource monitoring and data migration tools, and really simplifies management of data. Saying that, so we will jump into the Q&A.
I'll grab that first one, Murat. So
Yeah.
The question was, does OpenEBS support read-write MIDI? Not directly, but we have an actual solutions guide around using the NFS provisioner with OpenEBS underneath it to get a lot of the configuration and snapshot and cloning and other things like that, or possibly even replicating the other clusters. So it can be done with the NFS provisioner following our solutions guide.
Yeah, I think the short answer would be yes. Little bit of background of that. Why no and why yes. Yeah, technically speaking, OpenEBS, like you know, is a block storage, and the file system itself by design cannot be accessed by multiple nodes, but saying that all the similar solutions and the cache space are solving the issue similar way, running NFS or sometimes even MinIO on top of OpenEBS, and we have a integrated easy solution that you can find the YAML files in the GitHub repo. I think also on OpenEBS use cases it is mentioned. So let me try the next one. Is there a native support for backup restore? Can I easily export a volume and import it into another cluster volume, for example, a snapshot of PRD to overwrite current dev data with? Yes, and many of it, thanks to the Velero plugin, can be easily done. But Maya Online makes it more visual, and you can have it even a scheduled way. So you can take a backup and restore the same application and data, persistent data, even on a different Kubernetes cluster, on a remote Kubernetes cluster. In fact, this functionality is used for kind of disaster recovery on alternative high availability in production by many. So think it as so you can synchronously take a backup of your application and data to another cluster, and if something happens or zone goes down or data center goes down, you can easily bring it up. And the advantage of CStore and the tight integration with the FTO Valera additional snapshots are just incremental backup. So it's not a complete every time complete copy of the exact data. In that sense, it's very efficient thanks to the components of CStore. Who wants to take the next one? Let's see.
I'll grab it. All right. I was reading OpenEBS uses Rancher's Longhorn controller and are contributing back to it. What are the key differences between OpenEBS and full Rancher Longhorn? You mentioned Jiva was Longhorn, but I was also reading with new versions recommending CStore and full disks only. Can you further explain differences? Wait, I thought you originally deployed with Jiva and your dashboard showed CStore. No, I deployed with CStore in that particular demo. I showed that there was a Jiva storage class, but I created a new storage class leveraging CStore. As for the differences, Longhorn is written in Go. We wanted to see if we could develop a faster storage engine, so we wrote CStore in C. Also, there's more efficient snapshots and cloning and things like that with it. Yeah, for production deployments, we do recommend full disks instead of most of the time. There are use cases though where you can use, ephemeral storage or things like that, and use like essentially like our local PD or something like that. But in general, for most stateful workloads, we do recommend full disks and CStore. So I'll grab the next one too, Maran. The
And
disk.
I want to add a couple of
Oh yeah, go ahead.
things to the Jiva and the differences. So Jiva is preferred also when you don't have additional disks, and that might be the case on edge deployment or smaller deployments where you want to take advantage of the space available on the OS disk. So that because Jiva creates the sparse files. So it is used heavily on that type of cases. And technically, the difference, I guess, one question was Jiva versus Longhorn. So internally, storage engine part, although is same with a Longhorn, so the target that Jiva uses is ISTG, and versus I think Longhorn is using Go TGT as a target inside. Yeah.
I would also like to mention that Longhorn is still an open source project, but they're not currently support options for it.
Awesome, thank you. So the next question is, the disks presenting in the pool are stored where? It's virtual disk, it's block storage, in any block storage that you can connect to your device. In this particular example, I was running on DigitalOcean using DigitalOcean volumes, but it could be Google persistent disks, it could be physical disks attached to the node, or network disks in the data center, anything like that. Anything that the node recognizes as block storage, we can consume.
Thanks. So I'll try to answer the next one. Thanks, Arash. And by KubeCon, we were informed about Maya director on private environment. What are the plans? Yes, that is true. So now for our enterprise plan, we also have OpenEBS director. So what Patrick was showing demo of it, available as on-prem. If you are concerned about consuming cloud resources and or maybe completely running on-prem, and then you can also have Maya Online on-prem that is available to enterprise users. So, and I think this question is answered. Next one, how about Longhorn versus OpenEBS? Yes.
And then the next one is, can Maya Online be connected on existing OpenEBS Rancher? Yeah, you just go to mayaonline.io and you log in with either Google or GitHub credentials, and you go to clusters, add cluster, and name it, and it gives you that kubectl command that I showed before, but one specific for you. And you run that against your cluster, and you'll be connected up to Maya Online.
Yeah, technically, yeah, all clusters exist before you add into Maya Online, and Maya Online, that YAML file installs agents to collect. What are the best use cases to test OpenEBS? To test OpenEBS, well, OpenEBS runs in many enterprises today, but also very popular for smaller developer test use cases, because it abstracts storage layer, gives you exactly the same environment. Maybe you can create the same pipeline, and then that would run on everywhere. So benefits are, I think it's a long list, but so some of the top benefits what we hear from users, especially stopped by at KubeCon, and what's really appreciated, what they get with OpenEBS. If you run on cloud, So this is one of the actually top questions as well. Why would I run OpenEBS on top of EBS? But actually, if you are a user of EBS, you probably know the answer already, and because many reasons, and if your EC2 instance goes down in one availability zone and it may come back up in a different availability zone, then you lose access to EBS. And with OpenEBS, you can create a replicated volume across availability zones. In that case, will be available everywhere. And one of the, I would say, cost benefit of running OpenEBS is once you create an EBS volume, most of the time users create a larger volume not to deal with resizing it later, because you need to unmount and volume goes offline and many other mount-unmount issues may happen. So you can actually create a thin provision volume on EBS, and you can get a smaller EBS volume. And then later you can create additional volumes and add into your storage pools. That way you don't pay for unused space in advance. Yeah.
Also, just coming from an operations DevOps background, one of my favorite use cases is the one I demoed. Tools like Jira. You know, it's normally the Jira high availability story is a little bit more difficult. You have to set up NFS or something like that to replicate, and so I really like the ability to deploy it and just have the replicas in place, so I have high availability of the data, and let the Kubernetes scheduler worry about actually keeping the app pod up and running, and it just makes it pretty simple. So, so the next question is, does OpenEBS support all backend storage vendors like EMC, NetApp, IBM, and Ceph? And the simple answer is anything that looks like block storage to your node, we can use.
Yeah, anything mounted to the node, yeah, can be consumed, and in fact, all the vendors you mentioned are used in OpenEBS use cases. Yeah. How OpenEBS different from Rook? Yeah, so Rook is a storage orchestrator now, but if you compare to Rook running with Ceph, as you may be aware that Ceph, one difference is a scale-out storage solution. You need a Ceph cluster and you need to maintain it, you need to configure it, and these are all operational challenges, and on top of it also has a larger blast radius. So once you have a cluster, let's say a 3-node Ceph cluster, if a node goes down, multiple pods are stored on one Ceph cluster, experience that impact of node going down and recovery. And also some of the advantages we mentioned, granular control is not available with Ceph. Let's say your applications, like many databases today, NuoDB, Postgres, Mongo, Cassandra, you may prefer to have an application to replicate across nodes for one or the other reason. But yeah, this is an additional advantage. Then you don't have all this redundant storage used. You can choose to use local PVs with OpenEBS, or have a Jiva volume with single replica. Then you can let your replication replicate. So that's one difference. And also, yeah, after all, Rook with Ceph, Rook is a great project, and but with Ceph is known to be a bit difficult. Yeah.
Great. All right. So the next question is the Maya UI a cloud-only offering, or can I deploy it locally in case for air-gapped environments? So yes, right now it is a SaaS offering, but very, very soon we are coming out with MayaData OpenEBS Director, which will be an on-premises solution for version of Maya Online. It's going to be great. We're working through some of the specifics of the deployment model and stuff like that, but that will be coming very soon. So keep an eye on our website, and keep an eye on on our Slack channel, and you'll see as soon as that becomes available. I think we have 2 questions in chat too.
Let me switch over to chat. What is the difference between the free open source and paid version? Is the paid version also open source? So in terms of OpenEBS, there is no difference. It is 100% open source. But on the enterprise side, we have additional tools around it to make you quickly successful with tools like Litmus and backup and monitoring also and logging. So those are all management tools for OpenEBS, and also in terms of code. So as of now, they are the same bits, and it will stay the same bits because it is 100% open source. But so with the enterprise offering, we validate, we run a CI environment, and we make sure that OpenEBS that enterprise build, so which is the same code but might be coming from a different Docker repository as a build, is validated on all the platforms reported by our enterprise users. So that specific version validated on multiple Kubernetes deployment, on multiple managed Kubernetes environment, GKE, AKS versions, and also OpenShift and Rancher.
Yeah, essentially we're going to take version releases of OpenEBS and we're going to certify them. And that's going to be the core of the paid offering, along with support and the MayaData online, the Maya Online MayaData OpenEBS directory. I think we answered the last one already, comparing OpenEBS and Ceph.
Oh, yes, yeah. So again, what is the next step? So if you are ready to put OpenEBS into an enterprise plan, so where do you start? You can still take advantage of the special KubeCon offer. We provide professional assistant, 10 hours of help that includes not only OpenEBS, because MayaData is a data agility company. We want to make sure your deployment and your use case is successful. You get 10 hours of additional assistance, and you can find all these details on mayadata.io. So enterprise lab, if you are running in a smaller environment and don't require quick support, so that enterprise starter comes with 8x5 business hours and average response time 6 hours, and retention, my online retention, you get 7 days of logs stored for your environment. If you lose a Kubernetes cluster, the only way to understand what went wrong is to have the logs stored externally. Otherwise, your Kubernetes logs would be gone as well. So it's very useful functionality. And then you can send support requests through the website and tickets. So you get the expert advice on how to deal with stateful workloads, and all the deployment files for most popular use cases. We can also provide introductional training. And I think this concludes our webinar today. Thank you for attending, and thanks for great questions. And thank you again, Jason, for a great introduction. And we are proud of our partnership and what Rancher has brought to the community, simplified management of workloads on Kubernetes and management of Kubernetes itself. Thank you, Patrick, for a great demo.
Awesome. Thank you very much, guys. This has been a good one.
Thank you all. Appreciate it.